Lesson 60 is titled Balancing Chemical Equations, and before you get started, make sure and look at your rules for balancing chemical equations found at the beginning of the reading assignment. But Shormann Precalculus, it has a number of chemistry-related concepts, and we've done percent composition in Lesson 2, chemical mixture problems in Lesson 10, and other types as well. Whether you're currently taking a chemistry course or not, this lesson will help you think about chemical reactions and their connection to ratio. And ratio is one of the 10 major topics covered in Shormann mathematics courses. It's another example also of how the study of God's creation involves the comparison of this to that, unity and diversity, an attribute of God. This lesson assumes you already have a basic understanding of chemistry, so if you see like H2O, for example, that's not going to confuse you, and mentally you're like, okay, H2O, that's water, and for every 2 hydrogen atoms there's 1 oxygen atom, and it's understood there's 1 and not like 7 or something. Just we don't write the 1, kind of like in algebra, it's understood there's a 1 there. So stuff like that, hopefully that won't throw you off. And also, you've done some chemical reaction type of problems, and like chemicals on the left of the reaction arrow, those are called reactants. Chemicals combine. Sometimes they decompose, they break down, but mostly what we'll be doing is where they combine, synthesis reactions, where they combine to form new compounds, and those new compounds on the right, those are called products. So let's go ahead and get started here in example 60.1. There's just one problem here, 4 reactions in it. Balance the following chemical equations. So first up, we have oxygen gas and hydrogen gas, and under the right conditions, those would react to form H2O, water. To solve these problems, I thought it would be a good idea just to have the rules for balancing chemical equations on the screen, and then we can just rewrite the chemical reaction underneath and then balance it using the steps right above. So for A, we'll have O2 plus H2. So you write this on your paper as well. And you might want to leave some space, leave a little more space, because you're going to be putting coefficients in front of each compound, or you might be. So just leave yourself some room to do that. And so for A, oxygen and hydrogen react to form water. Step 1, it says count the total number of atoms on each side of the reaction arrow. So we see 2 oxygens there. We see 1 over here. And then for hydrogen, we see 2 on the left and then 2 on the right. So that's actually already balanced. And step 2, if any of the elements are not balanced, then change the coefficients to try and balance them. Never change the subscript. So again, that's a very important thing. You never change the subscripts. And again, this isn't a chemistry course, but just so you know, the reason you don't change the subscript is then you change the compound, because compounds, they are formed in specific proportions. So what you can't do for A is just go, oh, well, I'll just put a 2 right there, and now I have 2 oxygens on each side, 2 hydrogens on each side. Well, no, you just turned water into hydrogen peroxide, and that's a very different compound. So what we have to do then is just start on the left, the very far left, the oxygen. There's 2 of those. So how would we get 2 on the right side? We have to change the coefficient. The coefficient right now for hydrogen is 1. It's understood that there's 1 water over there. So we need to change that to a 2. 2 times 1 is 2 oxygens. So that's what step 3 says, right? Is work with 1 element at a time, then repeat steps 1 and 2 until the equation is balanced. So now we go back and we count. We see 2 oxygens on each side, but then we look at H2 and we see 1, 2 there, and then 2 times 2. Now we have 4 hydrogens on the right. And 2 times 1 is 2 oxygens. So what do we need to do to the hydrogen? Well, on the left, can't we just multiply that by 2 there? And so now we have 2 times 2 is 4 hydrogens on the left, and then 2 times 2 is 4 on the right. Check the oxygen again, and we're looking at step 4 as well while we do this. Keep the law of mass conservation in mind. Basically that just says you can't create or destroy mass, material, stuff. I mean, logically that makes sense, right? If you have 2 oxygen atoms, I mean, these are real things that we're considering here. 2 real oxygen atoms on the left. In a chemical reaction, you can't just add or subtract oxygens and lose them, or just spontaneously create more of them. So you have to have the same number on the right side. So, I mean, only God could do those kinds of things, like spontaneously create more oxygen. But in the world that He's given us, we can't do that. So we have 2 times 1 is 2 oxygens on the right, 2 on the left, 4 hydrogens on the left, 4 hydrogens on the right. Then the whole thing is balanced now. So if you want to, you can just erase all this other writing. And notice how you have to change things around too. You can't just assume that everything's going to stay the same the first time through or whatever. You may have to rewrite some things, erase some things. But there's the balanced equation there. Well, let's move on to B now. And let's just rewrite this equation, leaving some space. N2 plus 2H2. So that's nitrogen gas plus hydrogen gas reacts to form hydrazine. Under the right conditions, it would do that. We're not going to spend time talking about what those conditions are right now. That would be something you do in a chemistry course. But under the right conditions, nitrogen and hydrogen gas combine to form hydrazine is what that is. It's rocket fuel, actually. Sometimes it's used as a propellant, rocket fuel. So look at the atoms. Step 1, count the total number of atoms, and we see 2 nitrogens on the left, and also there's 1, 2 on the right. And then on the left for hydrogen, we have 2 times 2 is 4 hydrogens, and then we also have 4 on the right. So there's nothing to do here. This equation is balanced, and sometimes that will happen. So we wouldn't know that though unless we counted the atoms up. So that equation's balanced, and that's all you have to write for that. For C, let's write that equation down. CH4, which is methane plus oxygen. Methane gas and oxygen gas, if you use a spark, I mean that's like a fuel, you ignite that with a spark, it's going to combust, and the products will be carbon dioxide and water. So that's called a hydrocarbon because it has hydrogen and carbon in it, CH4. And that particular one is methane. So count atoms, and we have 3 different types here, right? 3 different elements: carbon, hydrogen, and oxygen. So a little more complex because there's 3 things to keep up with now, but shouldn't be a big deal. Count atoms: 1 carbon, nothing to balance there. 4 hydrogens on the left, 2 on the right, so that's not balanced. And then 2 oxygens on the left, and then look, there's 2 here and 1 here, so there's 3 on the right, so that's not balanced either. So starting with carbon, we'll just go element by element here. There's nothing to do with the carbon, so we don't worry about that one. But the hydrogen, 4 on the left, so if we multiply the H2O by 2, then we'll have 4 on the right, because this 2 times 2 is 4, right? So now go back through, we have 2 oxygens on the left, we have 1, 2, and then 2 times 1 is another 2. We have 4 oxygens on the right, so we'd need a 2 right here. Now we have 4 oxygens on the left, 4 on the right. So in chemistry, a lot of times, people know, oh, well, I know methane combines with oxygen to form carbon dioxide and water. And so they just write that down first. They write down CH4 plus O2 reacts to form carbon dioxide and water. So they know that part, but then they're like, okay, now how do I balance that? Is that balanced right now? And what's the exact amount of each type of molecule that combines? What proportions do they combine in? And so then they have to go in and balance it. And so that's what we're doing here, putting the 2 there, putting the 2 there. And now we have a balanced equation. So, or like somebody's doing a chemistry experiment and they have a couple of chemicals, they know the chemicals that they have, and then they analyze what the products are. It's like some new reaction, and then they say, oh, I got this and this as products. So what are my proportions here? And that's when they'll go in and they'll balance that equation. They write down the different compounds that were reactants and then what the products were. They write those down first, then go back in and balance it. So that's why we're balancing equations like this. That's why it's an important skill, because a lot of times you don't start with a balanced equation. You start with the compounds that you know of. So let's do one more, and maybe this one you could do on your own. This time we have ethane, C2H6, another hydrocarbon, plus oxygen, reacts to form, same thing as in C, carbon dioxide plus water. So we have a different, there's only one different molecule here, right? It's instead of methane, we have ethane now. But that's going to react in different proportions and form carbon dioxide and water in different proportions than methane and oxygen reacting would. So we count atoms. We see, starting with carbon, we already see a difference. 2 carbons on the left, 1 on the right. Hydrogens, we see 6 on the left, only 2 on the right. Oxygens, we have 2 on the left, 1, 2, 3 on the right. So starting with carbon, we'll put a 2 here because now we have 2 carbons on each side. And then think about the hydrogen, 6 on the left, so we know we could put a 3 here because 3 times 2 is 6 hydrogens. So go back and count through everything. Again, 2 carbons on the left, 2 on the right, 6 hydrogens on the left, 6 on the right, 2 oxygens on the left. But now we have 4 oxygens on the right there, and then 3 times 1 is 3. We have 7 oxygens on the right. So this one is a little more complicated. 7 oxygens here, 2 here. How would we balance this? How many do we need? Well, the way we figure this out is we use the least common multiple. And so that would be 2 times 7. I'll just say LCM. Least common multiple. 2 times 7 is 14. We need 14 on each side. So when you're not sure how many you need, when it's more complicated like this, that's what you do, is you find the least common multiple between the two and you use that. So that means we need 7 right here. And then if we double each of these, that to 4, that to 6, that would give us 8 and 6 is 14 oxygens. So we have 8 there and 6 there now. But think about it, we doubled that, so that means now we have 4 carbons on the right. So we need to put a 2 here. So now we have 2 times 2 is 4 carbons on the left. But then that changed the hydrogens too. Now we have 2 times 6 is 12. But fortunately, look, 6 times 2 is 12 hydrogens on the right. So that is balanced still with the hydrogens. So now everything is balanced. And so different ways you could do this. And if you're just using a pencil for all of this, write lightly for your different coefficients. Or you can just write a final equation here, 2C2H6, a final balanced equation, plus 7 oxygens, arrow, 4 CO2 plus 6 waters. So in the practice sets, a lot of times you'll have a problem and it'll just ask you what's the coefficient of oxygen gas, so the O2 in the balanced equation. What's the coefficient in front of the carbon dioxide for the balanced equation? So normally you'll still have to balance the entire equation to figure out the answer. So notice how we had to do steps 1 and 2 back, forth several times there, counting the atoms, changing coefficients, and then changing them again, even like we had to do on the carbon dioxide and water, until we got our final balanced equation. Okay, well that's all for lesson 60.